Hello, in this video I'm going to continue off where I left off from the last video, which showed my SoundMaker program, and also I went through the basics of the APU as well. So if you've not seen that video, then you might want to jump into that one after this video, as the sound effects which I present in here were made using my SoundMaker program. So first off, I will give a demonstration here. So I have a number of tunes which I've converted from sheet music, and I also have some sound effects using channel 1 and channel 4. So I'll go over the sound effects first. Okay, sorry, okay, so there's that one there. So that's my first sheet music for Star Wars there. Let's have a look, which one was that? Yeah, this is this one here, the main theme here. Okay, so I may as well go over the music now as soon as I've started. So I'll go for tune 2 now by pressing the B button. So that one apparently is the Imperial March, apparently. The notes I did there were just the treble clef ones here, these here and these here. Timings could be out, as in the sort of like pauses between the notes. Okay, so I'll now press the start button for tune 3. So that one was using the triangle wave there. So one thing to note first off is that because I don't have an NES, I obviously can't confirm whether these sounds in this emulator are actually accurate. I found with some other consoles that the emulators don't actually emulate the sounds correctly, so as I don't have an NES, I apologise if the sounds don't match. Okay, so now we'll go for tune 4, pressing the select button. I think you'll probably be able to guess what one that is. So that one is this one here. Again, just using the treble clef notes here. I will post links to these in the description to the video, but you obviously, once I jump into the code with this, you'll be able to see how the music was actually composed in arrays. So I'll now give some demonstrations of the sound effects on channel 1 first. So there's 4 sound effects for each channel just to demonstrate their use. So I'll now preview the other 4 on the noise channel. So as you can see, it's fairly straightforward to make your own sound effects if you use the SoundMaker from my previous video. Then literally just boot it up, tweak around with the settings until you've got some sounds that you want for your own game, write them down, and then just put them into an array So I will quit this now and we'll jump into the code for it, as I will be putting this up there for you to use for yourself. So the key things I want to go over in this really are the SoundManager code, which is what you'll use yourself. Obviously there's nothing with GBDK specifically, I don't believe, for using these. So I created, by looking at the GBDK header files, I'll come up with a load of names here for the channels which point to the actual registers here. These defines here are for playing music. These just set up the sound channel with bytes for us to use. So you could tweak around with some of these defaults to change the sound that's used for playing the notes. So the key parts here, so also there's an array of notes here, and if I open this one up, and this one as well, as they both work with each other to make creating music relatively painless. So there's 8 octaves here on the NES. As I said in the previous video on the SoundMaker, go from low, so the low number that you put in is actually high frequency, and then the highest number that you put in here, which is this here, is actually the lowest octave. So if I open up the calculator here, and then we can see that so the value 35E is actually 862. So that gives us the lowest note here on octave 3. But obviously for sounds which don't map to the notes, it obviously makes no difference here. And then this array here is literally just the delays, as in how long the note plays for, and also how long the pause after the sound being played. So these are kind of arbitrary here, they're variables. You can tweak these depending on the song to give better or worse results. GBDK only seems to output NTSC ROMs, so this might not quite sound right on the PAL machines. If you have a PAL machine and you're able to plug this program in an EverDrive and play the sounds, let me know if it sounds okay. So these enumerated notes here match the array here, so we can refer to these notes using this enumeration group here, which allows us to do this. So the songs are composed of how long they play for, the rest period between notes. So this period here, the song will actually be or rather the sound of this note will be stopped for that period of time to kind of break things up. And these here, so the play time and the actual note, you can get those from the actual sheet music. So I've got a number of different diagrams I use to help me do this stuff. I don't actually read sheet music here, but with the help of these diagrams here, it allows me to get a better understanding of what's actually in there. So this diagram here, along with this one here, allows me to decipher sheet music to some degree. So we can see here that the note types refer to how long they actually play for, and then in the sheet music itself, on the lines, using this one here, we can see what octave each of these notes actually are, which is obviously vital for us non-music reading people. So then we can take the sheet music. This one is nicely done for us, as it has the letters already on here, although it doesn't really give us an idea of what octave it is. But the difficulty is working out the delays between them, which is why some of the music I played there might not sound right, because you kind of have to play it by ear to some degree. It's like, how long is the delay between those two? We kind of know that this sound, the note there, is a half note, and it lasts for 2 beats. So each of these lines between these bars here represent beats, I believe. I could be wrong, but anyway, from our sort of perspective of, or rather my perspective of a programmer who doesn't actually write sheet music or read sheet music, being able to have these diagrams allows me to decipher them. And if you're in the same sort of position, I will give links to these to enable yourself to play around with these more easily. So plenty of sheet music online for you to have a play around with. And as you can see, we literally have to plug a byte for the pause, rest and delay for each note. So that's how these songs were composed. And then for the sound effects, they are pretty straightforward as well. So each sound for channel 1 or channel 2 requires 4 bytes. For the triangle channel or the noise channel, they both take 3 bytes each to generate a sound. So I'll put this here. So to play any sound effect from here, we just need to multiply by 4 to get to the start of each of these 4 bytes for the sound effect, and by 3 to get to the sound effect on channel 4. So there's 4 commands here which allow us to easily use these bytes here. So these commands here, sound C1, C2, C3 or C4, take in the respective bytes that the registers need, and then they plug those into the registers. So to make a sound on channel 1, plug those bytes into the 4 registers. So on channel 1, sound won't start until we've got a byte in 4003. Same with 4007, 4000 in B, and 4000 in F. So you can plug all of the bytes in the previous registers, and then it won't do anything until the last byte is put in. Then it will execute those commands that those bytes pass to the various bits in the sound registers there. So to start off with, to use any of this, you first need to call the sound initialize function, and then in the main loop just call sound update. So to turn on the sounds, what happens is in the initialize function, where is it? So first off, I make sure that all of the sound channels are turned off when we initialize. Otherwise you could get some sounds coming out before you do anything. So one thing that is weird is on the noise channel you have to write, I found that I needed to write 16 to that register, because putting 0 in there creates like a click still. So once you finish with a sound, you kind of want it to be off. So this sound channel off command is a useful one. It literally just zeroes the tone parts and the volume part of the pulse channels here. Obviously there's no volume setting in the triangle one, so all we can do is set the note frequency to 0, which will emit no sound. But the noise one, for some reason, we have to send 16 to the volume bits so that no sound will come out on that. So we clear the sound registers there, then we turn on the individual channels for the 2 pulse waves, the triangle and noise channel. So these are all done with bits. So as you'll see, the bits for them would be 1111, which is 15 in hexadecimal. Hence we turn on all the channels. We then disable the interrupt on the APU. And one of the other key things in here as well is I have a structure here for handling the music, which is fairly straightforward. We need to know when playing the music what channel it is, and then we've got a simple byte timer for the play time, the rest time. Then we have another byte here for the music offset in the music array. If I jump back to the music array quickly a minute, you'll see this is all bytes, so you can only have a maximum of 255 here, or rather 256, 0 to 255. Obviously, you could easily change that if you had like a long, some long music. You could always change this to be an unsigned 16-bit number. And then we have a play state variable here, which says what's actually going on. So that can be any of these states here. And then we have an array to our music data, and then just a boolean to say whether this is active or not. Literally all we do is we just to start off, you literally just send the array data to one of the music play commands here. I've also got a beep command in here as well, where you can literally just plug in a number and it will use the defaults for channel 2, and we'll just put the note frequency to channel 2 to play that. These are some variables which are just used internally with the SoundManager. It's all fairly straightforward once you get an understanding of how things actually work. The key takeaway from all of this really is that this will allow you to easily create sound effects for your own games and music, should you wish, without having to go through using external tools to create any of it, other than the SoundMaker program, of course, which is really useful. So as you can see here, the all the music tracks are defined in the main header there, so we can get at them, and the sound effect arrays as well. This is a carryover here, so this is not really needed at all. In fact, I will get rid of that. So it's very straightforward here. The just reading the joypad, depending on what you press, depends what channel we send the music to. So you could easily replace this for channel 3 if you wanted to see what it actually sounds like on that. And then the sound effects here, all we do is for the sound effects on channel 1, like I said, to be able to play a sound effect, we need to jump to offsets of 4. So we have a sound effect ID for channel 1, a sound effect ID for channel 4. The sound effect ID for channel 1 is multiplied by 4 using a bit shift. We then use this pointer to get to the relevant byte. Every time you press up, we increment the sound effect ID, so we can cycle through them all without having to worry about running out of buttons on joypad. If we get to the last sound effect ID, which is 4, then we loop back to 0, and then we just treat the unsigned char pointer as an array here and put the 4 bytes we need to play the sound. And that's pretty much exactly the same here for the channel 4 sound effect, except we multiply by 3 to get to the start of each of the sound effects there. So that's pretty much that's it for here really. I'll put links to the source code for this for you to download and use yourself, and I will also include the sheet music as well, so you can have a play around with that, and 2 of the aids that I use as well to save you from having to trawl the internet to try and find these things. If you've got an NES, let me know if it sounds okay on it. And that's it for this video. Hopefully you found it useful.